Hi Roger, how you doing mate?
Good.
Very good. Looking forward to showing you around the facility and give you a little bit of an understanding today of some of the processes that go into producing a high-end cooling system.
No, looking forward to it.
Thanks mate, come on in. So we've just purchased this i600 Vari-Axis. It's a 5-axis machining centre that we've coupled with the Palatech system here, and there's 6 pallets that are automated in terms of loading the machine, so we can run full lights out machining through the night, where we've got complex assemblies that are able to be machined and requires no operator through the evening to be able to do it. This is where we're building the cores. So this is the combinations of tubes and fins. What we've got is we've got a whole range of air fins that we can actually change the total height of the air fin. We can increase the density of the air fins, or we can actually decrease the density of the air fins. All about changing the thermal and the pressure drop characteristics of those fins. And it's the flexibility of our manufacturing processes and the ability to change densities, louver angles, fin gauges, fin heights. It all has an impact on the way that the air flows through the fin and ultimately its heat rejection.
Well Matthew, the heart of the new i600 Vari-Axis is the new SmoothX control from Mazak. Reputably one of the fastest CNCs on the planet as it sits at the moment. What's your expectations of where that's going to take your cycle times?
Our expectation, Mark, is that cycle time is going to be able to be significantly reduced over what we've been used to. Not only is it a new controller, but we're also running higher RPM on our spindle with the new Vari-Axis than we've ever done here at PWR. So coupled with the latest technology controller and higher spindle speeds, we're looking for big things.
How are your operators changing to the new graphical interface and touchscreen on the control?
It's so far positive feedback from the operators. You know, it's early days and they're coming to grips with the new software, but so far they like operating.
Big change from the earlier generation controls, isn't it?
Very much so.
Right, thanks Matthew.
So the wind tunnel facility that we have here is not necessarily what most people might envisage as a wind tunnel, because we're not doing specifically aerodynamic testing, even though the work that we do does have quite an impact on the aerodynamics of the vehicle. But we're not, for instance, looking to generate wind speeds of 300 kilometres an hour. We're actually just looking to be able to develop a wind speed and pressure that's equivalent to the air speed and pressure that the coolers are going to see in their installation within the duct. Whether it be water, whether it be oil, or whether it be air, we have cooling loops here to be able to simulate those conditions.
Hi everyone, my name is Matthew Nilsson. I'm the Technical Director here at the Holden Racing Team. You've just come from seeing some footage of the workshop tour of PWR and the use of the John Hart products. We're now here in Melbourne, Victoria, at the Holden Racing Team workshop, where you can see some of the applications that we use the PWR products. Predominantly, it's our cooling solutions, as you'd expect. Engine cooling for water and oil, and as well as the transaxle cooling for the oil in the transaxle. They're all PWR products that we use in conjunction with the design side with PWR to tailor it to our needs and our specific installations. So at the front here we have the water radiator. As you can see, this is a used product. We get good life out of them with the fin design that PWR have. Around the back here, you can see the oil cooler assembly that's contained within. So that oil cooler attaches to the water radiator. Up here we have our power steering fluid, so you can see again the constraints and the ability for PWR to meet tight demands for where we install these products in the car. They're always able to achieve that, you know, a bit of backwards and forwards between the engineering department here and PWR in Queensland, always achieves the end result that we want to achieve.